Hey you guys, so we want to talk a little bit about parent functions. Parent functions are going to be the most basic form of the graph and of the equation, and we have lots of different families of functions. Each family has its own specific characteristics that we want to make sure we know so that we are able to apply our domain and range, our transformations, all the other cool things that we learned. So the first function that we want to think about is our linear function. And its equation is y equals x. I know that it's linear because it's just an x. There's nothing else. My graph is going to look like a straight line moving in the positive direction. Another function that we're going to learn about is the quadratic function. This is one that we saw in Algebra 1 and Algebra 2. This one has the equation y is equal to x squared. I know it's a quadratic because I have a 2 in my exponent. This equation has the shape of a parabola, so my vertex is at the origin. It's my U shape, my parabola. You're going to have a few more functions to learn about. The next one we want to think about is our cubic function. The cubic function has the equation y equals x cubed. So I have a 3 in my exponent. Again, this is a vertex at the origin. It is going to continue up to the right, just like our quadratic, but it is going to be symmetric over the origin. It's an odd function. It will continue down to the left. Another function that we'll see is our absolute value function. So a value v. So I know that my shape here is going to be that of a v. My vertex is at the origin, and I'm going to extend in the positive and negative direction. So my equation here will be that y is equal to the absolute value of x. A few more functions that we want to keep in mind, y'all. We will have our square root function. That function, here we go. That function again will begin at the origin and then will continue in the positive direction forever. My equation is y. All right, our square root function, again, to recap, we begin at the origin and we're going to go to the right forever. And we have our equation is y is equal to square root of x. Uh-oh. There are two equations that are very similar, that are very, very related to each other. So our first one is going to be our logarithmic function. The second one is going to be our natural log function. So I know in both of these, my graph is going to have an asymptote along the y-axis, and we will begin going down forever, and then we will increase to the right forever. Same thing with my natural log. So the only difference lies in their equations, right? So my equation for logarithmic is y is equal to log of x. My assumed base is going to be 10. Whatever is in these parentheses is what I call my argument. The natural log, my assumed base is e. So the way that I write this in its most correct form is going to be y is equal to the ln of x. Right here, this is going to be my most perfect answer. Two more that we have, maybe. There we go. Are going to be my exponential and my rational. So when this is the case, here we go, you guys. My exponential function is going to have an asymptote along the x-axis. We'll have a y-intercept at 0, 1. And this right here, what we see is exponential growth. It is increasing forever. I know that my equation is an exponential equation because my variable is in the exponent. Finally, our rational function. That means I'm going to have an asymptote along my x and my y-axis, and I have these two branches. These branches are never going to touch each other, and this right here is also an example of an infinite discontinuity. I know that my equation is rational because I have y is equal to 1 divided by x. My x is always in my denominator. If you have any questions, please call me or Miss Gladney over.